The Arctic is facing catastrophic climate change. It is warming 3 times as fast as the rest of the planet, and between 1979 and 2016, the Arctic sea ice volume at the height of summer has reduced by around 72%. Black carbon, which makes up 1/5 of shipping's carbon dioxide equivalent emissions, not only causes warming while in the atmosphere, but also accelerates the speed of melting when it lands on snow and ice of the Arctic, exposing darker water and land surfaces. These absorb yet more heat and remove the reflective power of the polar regions, the albedo effect. Black carbon's impact on global warming over a 20-year period is over 3,000 greater than an equivalent amount of carbon dioxide. However, because black carbon is a short-lived climate pollutant, stopping emissions today will have an immediate effect, unlike mitigating carbon dioxide emissions. Limiting the emissions footprint of shipping in the Arctic is recognized by the European Union's 2021 commitment to take the lead on zero emission and zero pollution Arctic shipping. The Clean Arctic Alliance's campaign is focused on reducing ship black carbon emissions because of the disproportionate impact on the Arctic climate and environment. Over a decade ago, the International Maritime Organization was tasked with taking urgent action to reduce the impact of black carbon emissions from ships in the Arctic in order to provide a breathing space which would allow the development and implementation of measures to address the overall climate impact of shipping. However, a decade has passed and the IMO has so far only agreed on a recommendatory measure, a resolution which passes the responsibility for action to its members at either a domestic or a regional level. It urges a switch to distillate fuels and also calls on the shipping sector to voluntarily take action. Now, the latest advice from the Intergovernmental Panel on Climate Change is that the scientific evidence is unequivocal. Climate change is a threat to human well-being and the health of the planet, and any further delay in concerted global action will miss a brief and rapidly closing window to secure a livable future. It is clear that action by all sectors, including shipping, is urgently needed to reduce the impact of short-lived climate forces such as black carbon in the immediate term.
The EU's Fit for 55 package includes several proposals to tackle the climate impact from shipping. These include the Fuel EU Maritime proposal and the inclusion of shipping in the emission trading scheme. The first step should be to include black carbon in the proposed Fuel EU Maritime regulation, which is a greenhouse gas intensity standard. As the European Commission has already proposed to regulate both methane and nitrous oxide in the proposed greenhouse gas intensity standard, black carbon must also be included in a similar way. Secondly, black carbon and methane should be included in the shipping emission trading scheme, which is known as the ETS. At the moment, the Commission proposes only to regulate ship CO2 in both EU's ETS, but both methane and black carbon are short-lived climate forces, which also need to be regulated, and like CO2, need to be subject to a carbon price. Doing so will ensure that the decarbonisation signals from both the shipping ETS and the proposed Fuel EU Maritime regulation are aligned. Thirdly, a port-level rule can be applied that requires all ships calling at EU ports and operating in Arctic waters to only use cleaner fuels. This needs to be done at an EU level to avoid evasion and will lead to very significant reductions overnight in Arctic ship black carbon emissions. A switch to distillates also enables the fitting of diesel particulate filters, which will further cut ship black carbon emissions by over 90%. It's not possible to install and use these filters with the dirtier fuels such as heavy fuel oils, because otherwise they become clogged with particles. Therefore, switching to the cleaner fuels needs to be a priority first step. The International Maritime Organization resolution from November 2021 proposed addressing black carbon emissions from shipping in or near the Arctic and showed a switch to distillate fuels such as diesel will cut black carbon emissions by between 50 to 79% per ship, depending on the engine type. This proposal was submitted by Germany, France, Netherlands, Sweden, Finland, Norway, and Iceland, along with the United States, Canada, the United Kingdom, and the Solomon Islands. Black carbon makes up around 20% of shipping's climate emissions. Methane and nitrous oxide are quite rightly included in the proposed EU Fuel Maritime greenhouse gas intensity standard, despite only contributing less than half of 1% of shipping's climate impact today. Black carbon emissions can be addressed very easily, initially by switching to cleaner diesel fuels or other methods of propulsion. Other amendments are needed to ensure that Fit for 55 package delivers the EU climate law, but these are the top 3 priorities to reduce black carbon emissions from shipping.
So the European Commission has already proposed to regulate both methane and nitrous oxide in the Fuel EU Maritime Regulation GHG intensity standard, doing this by using default value emission factors and global warming potentials to calculate the CO2 equivalent emissions data for both these greenhouse gases. But the proposed regulation should be amended to include black carbon. Similar emission factors for black carbon are available and can be readily added to those already there for methane and N2O. Over time, the inclusion of more stringent GHG intensity ceilings will force ships to adopt measures or new fuels that will see CO2, methane, nitrous oxide, and indeed black carbon levels all reduced. The Fuel EU Maritime Regulation includes an annex which sets out default emission factors for all fossil fuels, split into upstream, that is well to tank, and downstream, tank to wake, to account for emissions from the actual combustion of these fuels in ship engines. Upstream emission factors account for the extraction, refining, and transport of marine fuels to ships. These emission factors are well known and accepted, and they're in the annex. The issue really is for downstream emission factors. Firstly, for methane slip in LNG engines. This methane slip is hard to measure, so the Commission proposes to account for it by setting default figures based on assumptions that vary according to the type of LNG engine. Also, black carbon emissions vary according to engine type, to engine load, and engine condition. So black carbon emission factors for ships will also need to be based on best estimates, as they have been for methane slip. But in the IMO's 4th greenhouse gas study, the analysis already used intelligent assumptions about average black carbon emissions per ship type. And importantly, the resultant inventory showed for the first time that ship black carbon accounts for 21% of shipping's climate warming impact on a GWP 20 basis. That's a huge percentage of ship warming that's never been previously acknowledged. Right up to this, you'll see a graph we'll put up showing the proposed black carbon emission factors for fossil fuels included in a new column 10 of the Annex 2 to the proposed regulation. These emission factors are tank to wake emission factors arising from the combustion in the ship engine. They are best estimates for all fossil fuels and vary according to the 2 main engine types, SSD and MSD. They're a compromise for black carbon, just as they are for methane slip. On the other hand, if verifiable direct measurements are available, then the proposed regulation will allow them to be substituted. Well, including black carbon will add new and significant incentives to reduce CO2 equivalent ship emissions. The reverse, not including them, would mean that over 20% of shipping's climate impact would be ignored under the Fit for 55 package. Including black carbon in the GHG intensity standard, either on a 100-year or a 20-year global warming potential basis, will result in higher overall CO2 equivalent emissions from all ships, which means it will be far more accurately account for the shipping's true climate impact. It also means that the GHG intensity standard 2020 baseline, which is yet to be calculated, will be higher than it would have been without including black carbon. But that's fine, as all ship CO2 equivalent emissions will accordingly be higher. The same occurred when black carbon was included in the IMO 4th GHG emissions inventory. Total ship CO2 equivalent emissions increased about 7% on a GWP 100 basis. Ships burning dirtier fuels which emit more black carbon will have higher CO2 equivalent emissions, so there will be more pressure, and it will come sooner, on ships burning these dirtier fuels to take measures to reduce their emissions, particularly if, as being proposed, the GHG intensity targets for 2025 and 2030 and beyond are strengthened to better align with the Paris Agreement. At the end of this segment, we'll show graphs of the CO2 equivalent performance of various fossil fuels, including LNG, plotted as grams of CO2 equivalent emissions per megajoule of energy produced, and plotted against a baseline in red for 2020 emissions. The baseline here is our estimate, as the Commission, as I said, is yet to calculate their 2020 figure. So the question is, what will be the first likely mitigation measure? The obvious and most economical will be for ships that are burning very dirty fuels to start burning fuels that cause less emissions. This is possible without any changes to ship systems or to refueling port infrastructure, and they can be dropped in. The most obvious initial measure of switching to cleaner fuels will be to burn more distillates. The cost premium to start using more distillates over heavy fuel HFO or very low sulfur VLSFO is less than 10%. On the other hand, to switch to biofuels has a cost premium over 200%. Switching to LNG requires a completely new ship or a major retrofit of an existing ship. And it's important to note that not all fuel has to be switched immediately, but rather there has to be a progressive transition to meet these increasing GHG intensity standards, so that the fuel costs will only increase incrementally. Unfortunately, such an incremental process will not deliver an immediate switch to cleaner fuels in the Arctic. So an additional command and control measure is needed, which we will explain separately. Well, you've got to first remember LNG is a fossil fuel, and it's basically pure methane. Methane slip occurs when uncombusted methane gas escapes from the engine into the atmosphere. Methane being a powerful short-lived climate force, the escaped methane undermines or cancels out most, if not all, of the LNG's lower carbon emissions advantages. Despite this, many promote LNG as a transition fuel while we wait for better, cleaner fuels, which might take another decade or so before being widely available. Switching to distillate fuels, on the other hand, and then installing diesel particulate filters involves manageable incremental costs that are far lower than the high cost today of burning LNG, even before the necessary cost of first building a new LNG ship or retrofitting an existing ship. Including black carbon in the carbon intensity standards puts the focus on cleaning up dirty fuels at a far cheaper initial cost. Already about 17% of ship fuel burnt under the EU's system of monitoring and verification of CO2 emissions is distillate fuel, and the transition to distillates can happen overnight. Indeed, many ships already switch between heavy fuels and distillates as they sail from emission control areas into the high seas. In addition, the heavier fuels that ships bunker at EU ports is imported from Russian refineries. EU refineries switched production to higher margin, more refined fuels many years ago. A switch to distillates means EU refineries can start producing distillate bunkers for EU MRV ships and stop the import of dirty heavy fuels with high black carbon emissions from Russia. Switching to LNG is not a solution.
Since the greenhouse gas intensity standard will not lead to an immediate switch to cleaner fuels by all EU shipping, an additional regulation, a command and control measure, is needed for those ships which use EU ports and operate in or near to the Arctic. In November 2021, the IMO adopted a black carbon resolution which passes the initiative to its member states and urges domestic and regional action to require ships to switch to using distillate or other cleaner alternative fuels or methods of propulsion. The proposed Fuel EU Maritime regulation is the right place to include a requirement that all ships, subject to the EU's system of monitoring CO2 emissions, must only use distillate or similar cleaner fuels if they sail in the Arctic. This one measure will cut shipping black carbon emissions impacting the Arctic overnight. We know this is possible because ships already switch between heavier fuels and distillate fuels as they sail through emission control areas in European and North American waters. And with a fuel cost premium below 10%, it is financially easier than switching to biofuels or LNG. Member states can implement this EU-wide measure using port state control procedures, and ship owners and operators should face stiff financial penalties if they don't comply. For this measure to be really effective, a workable definition of the Arctic maritime area is needed, which encompasses the wider area from which ships' black carbon emissions with the potential to have an impact in the Arctic are originating. And it was for this reason that the IMO's resolution refers to a switch to distillate for ships operating both in and near the Arctic. In October 2021, the EU's External Action Service issued a new communication which committed to leading the drive for zero emission and zero pollution shipping in the Arctic and promised faster and more ambitious emission reductions. This is very welcome, but the Clean Arctic Alliance is concerned that the communication seriously underestimates the assessment of ships' black carbon levels by restricting the area considered to the IMO's definition of Arctic waters. While this definition might be suitable for measures which address ship safety in ice-covered waters, it is not sufficient to address black carbon emissions from immediately beyond this boundary, which will settle out in a matter of days in the Arctic. It is essential that an amendment to the Fuel EU Maritime regulation applies to ships' black carbon emissions from a wider Arctic area. Fortunately, the Arctic Council's Arctic Human Development Report, which has also been used by the European Union, includes a suitable maritime delineation of the Arctic. Beyond this, and to have the full desired impact, black carbon emissions from ships sailing in and near to the Arctic should be further reduced through the installation of diesel particulate filters, as is required for land-based transport.
Including black carbon will initially provide an incentive across all EU shipping to move off the dirtiest fossil fuels to distillates in a manageable and cost-effective way. Later, as the intensity target becomes stricter, non-fossil renewable fuels will become part of the fuel mix. However, they're not yet readily available, but the alternatives to dirty black carbon fossil fuels are. So including black carbon can trigger more immediate mitigation action than will happen by the carbon intensity standard relying solely on the future development of the new renewable fuels. These new cleaner forms of energy will still take some years to scale up. In the meantime, the short-lived impact of ship black carbon can be addressed starting from 2025. This will make a critical and immediate contribution to reducing shipping's overall climate impacts and to keeping global temperature changes below 1.5 degrees of heating, while the longer-term transition to zero carbon fuels starts. The fuel cost premium of doing so for the next decade is small. It's less than 10%. So clearly there's also room to strengthen both the 2025 and 2030 targets from a black carbon perspective. To do so, we must use a global warming potential of 20 years, not a global warming potential of 100 years, as this more appropriately reflects the urgency of the situation and the fact that reducing short-lived climate forces such as black carbon and methane reduces ships' contribution to warming immediately. Time is of the essence, and the global warming potential of 20 clearly the most appropriate metric to use when mitigating short-lived climate forces like methane and black carbon. So the first step must be to include black carbon in the proposed EU Fuel Maritime regulation. Secondly, black carbon and methane should both be included in the shipping emission trading scheme. Thirdly, a command and control port level regulation can be applied, requiring all ships calling at EU ports and operating in the Arctic to only use cleaner fuels such as distillates.